Hello students, welcome back to today's class on coordinate geometry. In the last class we had discussed about area of the triangle in two different formulas, and now we're going to continue with some properties of or some formulas related to straight lines, and then we're going to discuss some problems based on all the topics that we have discussed, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's continue today's session. So, what is the first thing we're going to discuss about a straight line? You know what is a straight line? From the lower classes you're learning lines, right? So you know what is a straight line. This is a straight line, you can say. This is a straight line. It's a line. Okay, you can say this is a line segment. You can say this is a ray, right? So all these are some related to lines. This is a straight line, this is a line, the line segment, this is a ray. Correct? Now, for a straight line, can be drawn joining any 2 points. For example, if you have only 1 point, now tell me how many lines can be drawn using this point? How many straight lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on. Infinite points, infinite lines can be drawn passing through 1 point. But for a straight line to be unique, to be fixed, to fix its position, we need to have at least 2 points. We need to have at least 2 points. So 1 point is here and 1 point is here. So if you join this, you will get only one possible line. You cannot have infinite lines like this, right? So slope of a straight line. So what is the slope of a straight line? I told you just now, a line can be drawn joining any 2 points. For example, a point is here and the other point is here, right? You know what is a coordinate plane, what is a Cartesian plane, what is x-axis, what is y-axis. Let me tell you using that concept. It will be more easy to understand. Right? So, whenever a line is inclined with x-axis, okay, every line will be inclined with x-axis, right? So, that angle, whatever we are discussing here, whatever the angle is formed using some trigonometrical applications that we are not going to cover now. Okay, so we get something called a slope of a line. So slope is nothing but simply it says the orientation with respect to axis. Either it is in this way or whether it is in horizontal or vertical or inclined this way. So the slope is a parameter that says how inclined it is with the Cartesian axis. Right? So more about slope and more about geometrical properties of slope we are going to discuss later. But now let's try to understand where and how we are going to use the slope. How are we going to find the slope of a line joining 2 points? Okay, so slope of a line joining 2 points is given by slope is equal to y2 minus y1 by x2 minus x1. y2 minus y1 by x2 minus x1. This is a very important formula. Very important and very useful formula. I'll give you simple, straightforward 2, 3 and 4, 5. Find the slope of the line joining these 2 points. I ask, find the slope of a line joining these 2 points. This is x1, y1, this is x2, y2, y2 minus y1, 5 minus 3 by x2 minus x1, 4 minus 2. 5 minus 3 is 2 and 4 minus 2 is 2. So 2 by 2 is 1. So that is how you try to bring what is the slope of a line. Slope actually says that it's a orientation. It's a parameter to say the orientation or the inclination of the line. More specifically, you can say the inclination of the line. Okay, with which angle it is inclined with x-axis. Some trigonometric applications are involved in that. Okay, so and every line which is having the same slope, we can say these 2 lines are parallel. We can say these 2 lines are parallel. They have the same orientation. That means they should have the same slope. This line is having 2, 3 and 4, 5 having the slope 1. Some other point, some other line, if it is having the same slope again 1, we can say those 2 lines are parallel. So to get the lines are parallel, it is enough to find the slope of the line. Slope of the lines, right? Next one. So find the slope of the line passing through the points 4, minus 8 and 5, minus 2. Find the slope of the line passing through the points of 4, minus 8 and 5 comma minus 2. So x1 y1 x2 y2. So now the formula for slope we generally represent with m. Slope we generally represent with m, y2 minus y1 minus 2 minus of minus 8 by x2 minus x1 5 minus 4. Okay, so m is equal to minus 2 plus 8 by 5 minus 4 is 1. 8 minus 2 is 6. 6 by 1. Okay, find the slope of the line passing through the points 4 comma minus 8 and 5 comma minus 2. So minus 2 minus of minus 8 by 5 minus 4. Minus 2 plus 8 by 1. So that will give you 8 minus 2 as 6. Right? That is the slope of the line joining these two given points. Moving ahead, find the slope of the line joining 2 comma 0 and 3 comma 0. This is very important again. 2 comma 0 and 3 comma 0. You need to understand something here. I'll tell you what is that. First of all, let's try to understand the slope of this line. So x1 y1 and x2 y2. So we can say m is equal to y2 minus y1 by x2 minus x1. y2 minus y1 by x2 minus x1. So 0 minus 0 by x2 minus x1, 3 minus 2. So that will give you 0 by 3 minus 2 is 1. That will give you 0. So what happened? The slope is 0. What do you mean by slope being 0? That means it is not inclined with x-axis. That means if you carefully observe the points 2 comma 0 and 3 comma 0, 2 comma 0 is a point on x-axis as well as 3 comma 0 is also a point on x-axis. We are just trying to find the slope of the line, slope of x-axis. Okay, so from this information I can say that slope of x-axis is 0. Slope of x-axis is 0 and slope of any line parallel to x-axis will also be 0. Slope of any line parallel to x-axis will also be 0. Next, other point here you need to understand, you try to take few points on y-axis and try to find the slope of y-axis, and you please tell me what we will get using that slope of y-axis. Right? So moving ahead, find the slope of the line joining the points 3 comma 4 and 4 comma 5. 3 comma 4 and 4 comma 5. Quickly, y2 minus y1 by x2 minus x1. I am not even writing the formula. M is equal to y2 minus y1 5 minus 4 by x2 minus x1 4 minus 3. 5 minus 4 is 1 by 4 minus 3 is 1. So slope is 1. So very simple, very straightforward. Just in 1 minute, just in 10-20 seconds you can directly tell the answer. What is the slope of the line? y2 minus y1 by x2 minus x1. Right? So moving ahead, find the slope of the line joining AB and BA. So one point is A comma B, other point is B comma A. So slope is y2 minus y1 A minus B by x2 minus x1 B minus A. So if you take negative common, A minus B by A minus B will get, if you take negative common, so these will be value. This to you. Moving ahead, find the point comma 3b and a comma minus b. Simple. x1 y1 x2 y2. So what is the slope formula? y2 minus y1 by x2 minus x1 minus b y2 minus y1 minus b minus 3b by x2 minus x1 a minus 2a. So minus b minus 3b is a minus 4b by a minus 2a is a minus a. So these two negatives gets cancelled. So your final value of the slope of the line is a 4b by a. The slope of the line is a 4b by a. Right? So moving ahead. So one more point, 0 comma 4 and 4 comma 0. 0 comma 4 and 4 comma 0. You have x1 y1. You have x2 y2. So slope of the line is y2 minus y1 by x2 minus x1. So minus 4 by 4, which is equal to minus 1. So slope of the line joining 0 comma 4 and 4 comma 0 is minus 1. Right? So let's move ahead. A very simple, I'm just going a bit fast so that these are very simple questions you can try to do yourself using just one formula, y2 minus y1 by x2 minus x1. Right? Next one. Determine x so that 2 is the slope of the line passing 2, 5 and x, 3. So a line joining 2, 5 and x, 3 has a slope which we generally represent with m. Okay, which we generally represent with m. So slope is equal to 2. Slope is equal to, and what is the slope formula? y2 minus y1 by x2 minus x1. So y2 minus y1 by 3 minus 5 by x2 minus x1 x minus 2. Okay, that is a slope. So slope is equal to 3 minus 5 is minus 2 by x minus 2, and that slope is given as a 2. That slope is given as 2. So 2 and 2 gets cancelled. So you're left with minus 1 by x minus 2 is equal to 1. That will give you minus 1 is equal to x minus 2. So bring this minus to this side, becomes a plus 2. Minus 1 plus 2 becomes x. So x is equal to 2 minus 1. You will get x is equal to 1. You will get x is equal to 1. It is a very simple calculation. Okay, just the thing is, apply that formula, apply the slope formula y2 minus y1 by x2 minus x1, and try to remember the slope is already given as 2 and equate to that and try to find the value of x. A very simple question, right? Next one. So we have couple of practice questions. So let's try to practice them. Okay. So the area of the triangle whose vertices are minus 6, minus 2, minus 4, minus 6, minus 2, 5 will be. So A minus 6, minus 2, B minus 4, minus 6, C minus 2, 5. So we need to find the area, which is this is x1, y1, x2, y2 and x3, y3. So area is equal to half mod x1 times of y2 minus y3. I'm not going to do this one now. Plus x2 times of y3 minus y1 plus x3 times of y1 minus y2. So this is how you can try to proceed, right? So using all these values x1, y1, x2, y2 and x3, y3, just keep substituting here and you can try to find the answer. Okay, so please do it yourself. Let's move for one more question. What is the slope of the line passing to the points minus 2, 3 and 2, 7? Minus 2, 3 and 2, 7. The slope is equal to y2 minus y1 by x2 minus x1. y2 minus y1 by x2 minus x1. So 7 minus 3 by x2 minus x1. 2 minus of minus 2. 7 minus 3 is 4 by 2 plus 2 is again 4, which is equal to 1. The slope of the line joining A minus 2, 3 and B 2, 7 is 1. Okay, next question. Slope of the line, once again the same type of question, you can please do that. 2 minus 3 and 3, minus 4. This is x1, y1 and x2, y2. And you may ask me a question, sir, why are we taking always the first point as x1, y1 and then the second point as x2, y2? It is your wish. You take this one as x1, y, x2, y2, this point is x1, y1. You interchange the numbers, you interchange the pattern, okay, but the final answer will be same. But don't take x1 from here, y1 from here, x2 from here, y2 from here. No, x1, y1 will be together, x2, y2 will be together. Okay, so please be careful in that. So let me see that y is equal to y2 minus y1 minus 4 minus of minus 3 by x2 minus x1 3 minus 2. Minus 4 plus 3 by 3 minus 2 is 1. So minus 1 by 1. Slope is equal to minus 1 by 1. Okay. So moving ahead, the distance between the points minus 7, 2 and 5, minus 3. Distance between the points. What is the formula for that? What is the formula to find the distance between 2 points x1, y1 and x2, y2? So slope is equal to, distance is equal to, not slope. We are trying to find the distance between 2 points. So the formula for distance is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. x2 minus x1 whole square plus y2 minus y1 whole square. It is x1 y1 and this is x2 y2. That will give you root over x2 minus x1 5 minus of minus 7 whole square plus y2 minus y1 minus 3 minus 2 whole square. Okay, so 5 minus of minus 7, that is 5 plus 7. 5 plus 7 is 12. 12 square plus minus 3 is minus 5 square. So 12 square, root over 12 square is 144. 12 square is 144 plus 5 square is 25. So root 144 plus 25, 144 plus 25 is 961, and root 169, if I am not wrong, which is equal to 13 into 13. So that answer will be 13. The distance between these 2 points, minus 7, 2 and 5, minus 3 is 13. Okay, so moving ahead for the next question. So please quickly copy this one. So let's try to go for the next question, right? So what is that? AOBC is a rectangle. Okay, let me draw rectangle first of all. AOBC is a rectangle whose 3 vertices are A 0, 3, O 0, 0, and B 5, 0. We don't know what is the C, X, Y. Then length of its diagonals is length of its diagonal. Okay, so I think for length of diagonal, I don't think X and the other vertex is required. In a rectangle, both the diagonals are equal in length. Both the diagonals are equal in length. So just try to find what is the distance between A and B. You will get the length of the diagonal. Okay, so AB is equal to root over x1 y1. This is x1 y1, let's say, and x1 y1, and this is x2 y2. So x2 minus x1 whole square, 0 minus 5 whole square, plus y2 minus y1 whole square, 3 minus 0 whole square. Right, sir? That is the distance between 2 points formula. So 0 minus 5 whole square is 25, plus 3 square is 9. Root 25 plus 9 is root over 34. So root 34 units is the length of the diagonal AB as well as the length of the diagonal OC. Even OC length will be root 34. In a rectangle, both the diagonals lengths are equal and they are same. Okay, so moving forward for the next question. Find the coordinates of the point which divide the line segment joining 4, minus 3 and 8, 5. Right? Find the coordinates of the point which divides the line segment joining the points 4, minus 3 and 8, 5 in the ratio 3:1. In the ratio 3:1. So we have the formulas, right? So this is x1 y1 and this is x2 y2, and you have the formula for M/N ratio. So that formula is being sometimes M/N or M1:M2. It depends on the book we are following. Okay, the point is mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. So what is mx2? mx2, 3 into 8, 8 3 is 24, plus nx1, 1 into 4 is 4, by m plus n, 3 plus 1 is 4, my2, 3 times of 5, 15, plus ny1, 1 into minus 3 is minus 3, by m plus n, 3 plus 1 is 4. So 24 plus 4 is 28, so that will give you 28 by 4, 28 by 4, 15 minus 3 is 12 by 4. 15 minus 3 is 12 by 4. So 28 by 4 is 7 and 12 by 4 is 3. So the point which divides the line segment in the ratio 3:1 is the point 7, 3. Is the point 7, 3, right? So moving ahead for the next question. Find the values of k for which the points are collinear, and I told you. Now let's try to discuss the same collinearity condition in other sense, not through the area of the triangle but through the slope of the line. Okay, I said these 3 points are collinear. Let's say ABC. The points ABC are collinear. A 8, 1, B k, minus 4, and C 2, minus 5. These 3 points are collinear. That means they are on the same line. That means the inclination of AP and BC will be same, right? So I can say that slope of AC, the complete line, is equal to slope of AB. You can also equate the slope of BC, whatever it is. Okay. So what is slope of AC? How to get that? What is the slope formula? y2 minus y1 by x2 minus x1. Slope of the line joining 2 points, y2 minus y1 by x2 minus x1. Okay. So y2 minus y1, let's say about AC. x1 y1, x2 y2, y2 minus y1 minus 5 minus 1 by x2 minus x1, 2 minus 8. That is the slope of AC. Should be equal to slope of AB. y2 minus y1, now this is y2 minus y1 minus 4 minus 1 by x2 minus x1, that becomes a k minus 8. Minus 5 minus 1 is minus 6 by 2 minus 8 is again minus 6 equal to minus 4 minus 1 is minus 5 by k minus 8. So minus 6 and minus 6 gets cancelled. So you're left with 1. 1 is equal to minus 5 by k minus 8. Cross multiply. K minus 8 is equal to 5 minus 5 and bring this minus 8 to the other side. K equal to plus 8 and minus 5. So 8 minus 5 value is 3. Right? So this is how you can try to find collinearity condition using the slopes, or else you can also go with the area of the triangle making that to be 0, and ultimately you should get the same answer back. Okay, if there is any calculation mistake, just please try to rectify that. Okay, so the next question we are having, the area of triangle ABC with the vertices is, again, the area of triangle. You know what is the point, what is the formula, right? I am not going to do that. Area is equal to half mod x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So using this relation, you have all the points x1, y1, you have x2, y2, and you have x3, y3. So please try to substitute here and try to bring the answer. Okay. So in the same way, we have a couple of more questions. Find the distance of the point from the origin. Minus 6, 8 and origin is 0, 0. How to find the distance? Root over x2 minus x1 whole square, x2 minus x1 whole square plus y2 minus y1 whole square. Root over 0 minus of minus 6 whole square plus y2 minus y1 whole square, 0 minus 8 whole square. So minus of minus 6 is plus 6, 6 square is 36, plus 8 square is 64, 36 plus 64 will give you 100, and you know root 100 is 10 units. Root 100 is 10 units. That is how you can try to find the distance between the point and the origin. Okay, so in that way, a couple of more applications are there which we are going to discuss in one more lecture. So I hope you understood this lecture, and thank you so much, friends. Stay tuned to get the next lecture. Thank you.
Yeah. Hello everyone. So now we'll be discussing about power of a lens. Okay, my name is Shishir Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. So first of all, we'll continue with defects of vision. Right. So in the last class or until now, we discussed about myopia and we discussed about hypermetropia. Both of them are done. But we haven't discussed about presbyopia and cataract, and that's what we'll discuss now, and after that we'll go into power of a lens. So very quick revision of myopia and hypermetropia. Only the basic points: myopia and you can say hypermetropia. In myopia, what can you see? In myopia, we can clearly see near objects, but we cannot see far objects. You can say that far objects are not clear. Far objects are not clear. Whereas in hypermetropia, what happens in hypermetropia? Near objects will not be clear, but far objects will be clear. So I can say near objects are not clear. Near objects are not clear. So when you talk in terms of far point and near point, here far objects are not clear, that means far point has come closer. Far point comes closer. Whereas in the case of hypermetropia, we cannot see near objects, that means our near point has gone farther. Near point shifts away. Shifts away from the eye. When I say away, away from the eye. Right? And in the case of myopia, image is formed in front of retina. Image is formed in front of retina. Very important but basic points again. Whereas in the case of hypermetropia, image is formed behind the retina. Image is formed behind retina. So all of you should be able to remember these points accurately. Okay? And again, another point that we have, the corrective lens. For myopia, which corrective lens is used? Concave lens is used. Whereas for hypermetropia, convex lens is used. Right, so these are the main differences, or you can say the basic points regarding myopia and hypermetropia. You know all of them. Good. Now let's go into presbyopia. Now we have already learned about power of accommodation, and because of this power that we have, we can easily focus on near objects as well as far objects. We can focus on near as well as far objects. Right, and depends on what this power of accommodation is enabled by ciliary muscles as well as our eye lens because of their flexibility. Right, so as you grow old, what happens is that flexibility reduces. It could be because of ciliary muscles or it could be because of the eye lens itself, but that flexibility reduces, decreases with time. So with age, as you grow old, flexibility of lens in the eye reduces. And ciliary muscles also get weak. This makes it difficult for what? You are losing your power of accommodation. Right, so this makes it difficult to focus on near and far objects at the same time. That means you will not be able to see near objects as well as far objects. So you have both myopia and hypermetropia. The reason is different, old age, but you have both of them. Is that clear? So this makes it difficult for the eye to accommodate near and distant vision, both of them. Okay, so the near point comes closer and the far point comes nearer. Both of that happens. Got it? Good. And how do you correct it? See, we are not able to see near objects as well as far objects. It's like both myopia and hypermetropia. Then we should use both convex and concave lens. So we should go for their combination. That's why we use something called as bifocal lenses. Now what are these bifocal lenses? They'll have two types of lenses. For example, look at this image. Can you see the image here? There are two types of lenses. A better image is given here. Right, so the upper part is for distant objects. The lower part is to look at near objects. Right, so here you can see they have convex lens at the bottom. So this here for near objects we use convex lens, and concave lens at the top for distant vision, for looking at distant objects. Is that clear? Good. Now I'll give a simple example. Have you seen old people using, old people like you can grandfather, grandmother, right, elderly people, they, when they read their newspaper, they keep their specs in this way, like on the nose. Have you noticed that? Yes or no? Why do they do that? It's not out of habit or out of style. It is necessary because They have to use what? To look at the near objects, they have to look through the bottom of the specs. They have to look through the bottom of specs, so when they keep it on the nose, it will be easier for them. Then they can look through the bottom of the specs. That is the reason. Right, so as you grow old, there are chances of presbyopia. Right, and then we use bifocal lens. Got it? It's mostly because of what? Mostly because of old age. With old age. Good. Then there is another defect called as cataract. That is completely something else. Here what happens is, on your eyes, okay, on your eyes itself, there will be a layer formed. A layer will be blocking your vision. A layer will be blocking light from entering the eyes. Yes, and that layer formation is nothing but cataract. What is that layer? That layer is a lump of proteins. So again, it also mostly happens in old age. Proteins in the eye lens can clump together, making it cloudy or even opaque. And what does opaque mean? It does not allow light to enter. And if light does not enter, you cannot see. Right, so there will be a layer formed, a layer because of what? Proteins in the eye. This leads to decrease or loss of vision. So how do we rectify it? We rectify it by using, it is rectified only by surgery. So through surgeries, that layer can be removed. So cataract is corrected by surgery. It's very common. Okay, it's very common nowadays among old people. Okay, good. So we learned about the defects of eyes, presbyopia and cataract. Okay. Now we'll be starting with power of lens. Before that, let's go into a simple problem here. What is the problem? A student has difficulty reading the blackboard while sitting in the last row. So in the back bench. He's a backbencher, right? So from the back bench, that student is not able to see the blackboard clearly. What could be the defect the child is suffering from? How can it be corrected? Yeah, which defect can it be? That student, he or she, is sitting in the last bench, the back bench, and is not able to see the blackboard. That means that student is not able to see far distance. Obviously, blackboard will be far. So if he or she is not able to see the blackboard, he or she is not able to clearly see far objects. If he or she is not clearly able to see far objects, that defect will be myopia. It will be myopia. And you might be asking, sir, why not presbyopia? In presbyopia also you cannot look at far objects. Agree, but presbyopia mostly occurs in elderly people, old people. But here we have a student. Students are young. So it cannot be presbyopia. It should be what? It should be myopia. And the next part of the question is, how can it be corrected? How do you correct myopia? How? Which lens do we use? Yeah? We use a concave lens. We use what? We use concave lens. So using a concave lens, it can be rectified. It can be corrected. Got it? Good. So now we'll go into power of a lens. Now, for those of you who have sight or who use specs, right, obviously specs has lens. But we don't talk in terms of focal length. We talk in terms of something called as power. Which power or how much power do you have? -1, -1.5, -2, -0.5. Right, we talk in terms of something called as power. So what exactly is this power? Right, so let's understand that. Now let me take a lens. I'll take a convex lens. I'll take two cases. Okay, let's say in this case, the focus is here, and in this case, the focus is bit far away, somewhere here. Okay. Now I'll be taking parallel rays. Okay, one ray is enough. I'll take a ray parallel to principal axis. What happens to it after passing through the convex lens? It converges or it passes through a point on the principal axis called as focus. Simple enough. The same thing, I'll again take a ray parallel to principal axis in this case also. And what happens in this case? The same thing happens. Right, it passes through a point on the principal axis called as focus. The question is, which lens, the first lens or the second lens, which lens is bending the ray more? Which lens is bending the ray more, 1 or 2? Yeah, everyone? 1 or 2, which lens is bending the ray more? Yeah. And the answer is 1. 1 bends the ray more. 1, and say lens 1 bends the ray more. Why? How? Let me explain that. For that, I'll again take a convex lens. Okay. Let's say this is a convex lens. Now what I'll do is I'll take two special cases. In the same itself, in the same diagram itself, I'll take those two cases. Now, this is the incident ray. Let's say this is one case when the focus is here. And let's say this is another case. And if this another case, the focus is here. Okay, so I am shifting what? I am shifting the focus. And when you shift the focus, automatically the focal length also will change. Automatically the focal length will also change. Now let's discuss about that. So let's say this is case 1, this is case 2. And here, if I just look at the bending, now this blue color dotted line is supposed to be the direction of the ray. Now this is the direction of the ray. If there was no lens here, the ray will be going straight. If there was no lens, the ray would have been going straight. But there is a lens, so there is bending. Now see what or which lens or which ray is bending more. Can you see? This is for ray 1 and this is for ray 2. So which ray is bending more? Ray 2 is bending more. And for ray 2 or for ray 1, in which case is the focal length less? The focal length is less for ray 2. Yes or no? This ray 2. The focus is here. So only this much is the focal length. So here you can clearly say a point. Lesser the focal length, greater is the bending. You can say convergence, it's fine. Greater is the bending of ray. Clear? See, again, just look at that carefully. We have taken two cases, two different focus, that means two different focal lengths. And we have looked at the bending. In the second case, the bending is more, and in the second case, the focal length is less. So, lesser the focal length, greater is the bending of the ray. Clear? And what is power? Power measures the amount of bending of ray. How much can a lens bend a ray? Okay. So, greater the bending of ray, greater the power. Greater the bending of ray, greater the power, because power measures what? The bending of ray. That is the reason. So we can say that lesser the focal length, greater is the bending, and that means bending is greater will mean greater is the power. So lesser focal length, greater power. Lesser focal length will imply what? Will imply greater power. So what can we say from this? We can say that power is inversely proportional to focal length. Power is inversely proportional to focal length. Lesser the focal length, greater the power. And using this itself, we define power as this. That's it, a very simple definition, straightforward definition. Power is defined as the inverse or the reciprocal of focal length. The reciprocal of focal length. Clear? So let's go into the definition here. The degree of convergence or divergence of light rays. And when we say convergence or divergence, it ultimately means the degree of bending of light rays that can be achieved by a lens is expressed in terms of its power. So the reciprocal of focal length is called power of lens. That's it. Straightforward definition. One simple form definition. This is the definition, by the way. That's it. Power of a lens is the reciprocal of what? Focal length. Now generally, focal length can have any units, and generally most of the questions that we come across will be in centimeter. Right, so depending on the units of focal length, formula slightly changes. Or else you can just remember one formula. Power is equal to 1 by focal length in meters. So if the focal length is in meters, you directly take it as 1 by f. For example, example 1, focal length is equal to 2 meters. Then we directly take power as what? 1 by 2. Because focal length is in meters, we can directly use the formula 1 by f. So 1 by 2, it is 0.5. Okay, so the denominator should be in what? Should be in meters. But if I take another example, let's say focal length is 20 centimeter. But what is 20 centimeter? In terms of meter, 20 by 100 meters. Yes or no? So then power will be equal to what? 1 by 20 centimeter, which is 20 by 100. How much is that? 100 by 20. That is equal to 5. That is equal to 5. So look at this. When we are taking it in terms of centimeter, we can directly make use of this formula 100 by focal length in centimeter. Right, that's why we have this formula. For our convenience, we define two types of formula. One is directly 1 by focal length when the focal length is in meters, or 100 by focal length when it is in centimeter. Got it? So very simple formula, 1 by f. The only thing we have to be careful is whether the units are in meters or in centimeters. Now you might ask me, sir, what if the focal length is in millimeter? Then just convert that into centimeter, use it, or convert into meters. Or else if you need, you can say 1000 by focal length in millimeter. But mostly you will not come across millimeter, it will be in centimeter. Got it? And one more important point that we have is the SI unit of power is something called as diopter, and the symbol is capital D. And for SI unit, what is the SI unit going to be here? Just look at this. 1 diopter, power is what? We are taking power as diopter, the SI unit. So 1 diopter is equal to 1 by 1 meter. Focal length is also in SI units. 1 diopter is equal to 1 by 1 meter, or you can say 1 diopter is equal to 1 per meter, because meter is in the denominator. So what is diopter? It is the SI unit. It is the SI unit of power. Symbol is capital D. Very, very, very important point, because normally people forget that. That is the reason. Got it? Good. So let's go into a few problems and to understand things better. Here, if a doctor has advised you to use a lens of focal length 2 diopter, what is the focal length of lens? Sorry, there's a slight mistake in the question. It should have been what? To use a lens of power 2 diopter. It should have been to use a lens of what? Power 2 diopter. What is the focal length of the lens? What is that going to be? Let me solve this from next question. I'll leave it to you. So what is given here? A simple power is given. Given information. Power is equal to 2 capital D diopter. But what is power? Power is equal to 1 by focal length in meters. But if I look at the options, see the options 200 centimeter, 100 centimeter, 50 centimeter and 25 centimeters. So what is the unit of focal length? Centimeter. So we need the focal length in centimeter. So what I will do is, here I'll take the formula as 100 by F, but the focal length that we get will be in centimeter. Right? So power is 100 by F and the power given is 2 diopter. Right? Then just do the calculation. Right? 2 comes to this side, F goes to that side. F becomes 100 by 2, that becomes 50, right? And we get the focal length in centimeters. The focal length is how much? 50 centimeter. How much? 50 centimeter, and hence the answer is what? The answer is option C. Clear? Take it down, very simple. Quickly take that down. Given information, the formula for power, substitute and we will get it. Done? So we got the focal length. Right. Good. Now we know that for different lengths, right? Like you can take example of concave and convex. The focal length can be positive or the focal length can be negative. Does that mean that power also can be positive and negative? What do you think? And for most of you, in fact, almost all of you, right? For those, like all those of you who have specs, who have a sight, what is your power? If you look at your prescription, it will be written as negative power. -1, -0.5, -0.75, -1.25. The power will be given in what? Negative terms. That means power can be negative. Yes, it can be negative. And it depends on what? It depends on focal length. So when I say P is equal to 1 by F, F is positive, power is positive. Simple. F is negative, that means what? Power is negative. So whether power is positive or negative will depend on what? Focal length. Easy, right? Very easy. Yes. Good. So now an interesting question based on that negative power and all. The question is, lenses with negative power are converging lenses. Is the statement true? Yes or no? I'll give you 30 seconds of time. Compare it with the focal length. Okay, when you compare it with the focal length, then you will get the answer. 30 seconds of time. Please solve it. Lenses with negative power are converging lenses. Think in terms of focal length. Got it? Ten seconds more. 5, 4, 3, 2, 1, and the time is up. Okay. So here, how shall we do it? And first of all, what do converging lenses mean? What do diverging lenses mean? Right. The best example that we can think of will be what? Will be a convex and a concave lens. Here, as you can see, these are what? These are converging lenses. And which example do we take? We take a convex lens. Right, and this is what? Converging, because it converges the rays. That is the reason. Converging. And here, the focal length is positive or negative? Yeah? The focal length in this case is positive. That means power is positive. Focal length is positive, that means power is positive. Simple. Right? Now, similarly, if I take a concave lens, principal axis, and then if I take incident parallel rays, what happens to them? They will refract in this way or they will diverge. Right, so here concave lens is what? A diverging lens. Concave lens is what? A diverging lens. And what about the focal length? The focal length is negative. And the power is what? The power will be negative. So what does that mean? What it means is, whenever we have positive power, it will mean a converging lens, and whenever we have negative power, it means a diverging lens. Negative power will mean what? Diverging lens. So keeping this in mind, if I come back to the question, lenses with negative power are diverging. What is mentioned here? Lenses with negative power are converging lenses. Is the statement true? Is the statement true? No, the statement is false. The statement is false. Okay? Good. Next. The same point, the point that we have discussed is given here. Converging lenses have positive power, diverging lenses have negative power. Good. So another simple question for us. What is the focal length of a concave lens? Acha, again, a slight mistake here. What is the power? My mistake. What is the power of a concave lens of focal length 25 centimeter? And we have a few options. Okay. So let me give you how much time? 30 seconds? Yeah, 30 seconds will be enough. Focal length is given, you have to find out the power. So a simple, straightforward question. So please solve it. What is the power of a concave lens of focal length 25 centimeter? It is a concave lens, so you have to be careful. What is the power? Yeah? 5, 4, 3, 2, 1. The time is up. Got it? Good. So how do we do this? The focal length is given as 25 centimeter. But which lens do we have? Concave lens. And for concave lens, the focal length is negative. So F is equal to minus 25 centimeter. F is equal to minus 25 centimeter. That means power is going to be 1 by F. But F should be in meters. Here the F is in centimeters. So we can take 100 by F. Simple. Right? So P is equal to 100 by, what is F? F is minus 25. So minus will remain. 100 by 25 is 4. So minus 4. What about the units? Capital P, capital D. And capital D refers to diopter. So the power is minus 4 diopter. And hence the answer will be option A. Clear? Good. So that's it, everyone. So we have discussed about presbyopia, cataract and power of a lens. Okay, so thank you. Thanks a lot.